is this. Most of the time, if you're using this idea, this is what you want to know. You want to know the average value of a function. What was this function's value over the course of this thing? If you have some random function here, and you want to know, okay, it goes up, it goes down, who knows what it is. If we want to know its average value, here's what you're going to do. You are going to take the area underneath the curve, and you're going to take the width of the interval over which you're looking. If you want to know the average height of that, you say this is A, this is B. If we want to know the average height of that curve somewhere, wherever it is, we don't even care where it is. We could find where it is after, but if we want to know the average height of the curve, average value of that function, you can rearrange this formula. The average value is f of c. How do I rearrange that? We've got f of c is equal to
that area divided by width.
That area, a, b, f of x dx divided by b minus a. Math people, for whatever reason, don't tend to write things like this. They don't take a whole integral and divide it by that. Instead, what they do is, where do they put this?
Over top.
No.
Beside it.
Beside it, right here. But then they don't need such a big line there, right?
1 over that.
So what they usually do is they lasso it and make it smaller, or they just delete it and redraw it. 1 over, right?
Oh, like that.
Okay? This is the average value of a function. People tend to look in the textbook or in their notes and say, what the heck is that? I have no clue what's going on there. All this is, let me reiterate this is the area under the curve. Area under curve divided by the width of the interval gives you the average value. Okay? Average value. Average value of f. And this is width of interval. Width of interval. This is if you want the average value from A to B, right? I left that out. And the last thing is area under curve. Under curve from A to B. If you want the average height of some curve, let me give you simple things where you can calculate this without calculus. Here's a curve for you. It is a straight line, horizontal line that is at 5. What's its average value from 1 to 3? 5, thank you, right? Because it's a horizontal line. Even if it was a sloped line here, if it went from 0 up to 4, what's its average, if its average height was 0 up there, it's 4. What's its average height? 2, because if you equaled it out here and said, well, half the time, it's kind of going like this, its average height is 2. That's because it's steady the whole time. If it goes like this, let me show you something. Intuitively, if I do this, pretend that this was the curve. What do you think its average height is there? This is the key moment here. Okay? How does its average height compare to 2, compared to that nice straight line there? The average height is going to be what? Higher. Why is it going to be higher? There's more curve up top. Or in other words, it gets up to this high value really quickly and then kind of levels off. What about if it went down here? It's going really slow down here and then it's going to be a lot lower than 2. There's not a lot of area underneath there. Why would you do that? I like to tell people, I tell my grade 8s this, but I think I might have to retract some of these statements. I say the older you get, the more mature you get and everything like that, right? Because for grade 8s, I tell them, I think I've even told you this, I coached my 6-year-old soccer team. They just say random stuff, okay? they say random things, right? I'm sure I've told you this, but they say, I'm saying, okay, we're going to do this drill. You see these cones here? We're going to do this and this and this. Yes. My cat had kittens. Like and so to grade 8s I was saying, well, when you're 6, that's what it's like, right? You're just totally random thoughts all the time. As you get older, did your cat have kittens? I know it's going, okay? Yes, I'm sorry. I do. He already asked me. Okay. I can't impress this upon you enough because I'm pretty sure you can go through and calculate this. Because there's a lot of, you're very good math students, but sometimes what we're lacking is the understanding of what you're doing. If you have whatever random function here, okay, if you have some function that went like this and it went way up here and zigged and zagged, that's going to have a higher average value than one that was way down here, right? If these were the value of 2 investments, the black one has been better on average over the whole time, right? What it's worth at the end, we're not talking about. We're talking about what's the average value over the course of the thing. The way you do it is you equal out the area and divide by the width. Or in other words, you take the integral, all the area underneath. Like if you want the average value of that black curve, if you want the average value of the black curve there, you take all the area underneath and divide by the width of this interval. Or in other words, you say 1 minus, for this, if this function was called p of x here, the average value of p would be 1 over 3 minus 1 times the integral from 1 to 3 of p of x dx. That would give you the average value. Are we okay with this? I'm not doing any number. This is special. This is bonus features, okay? This is yeah, that's right. Why do I say things like this?